So this brings me to my next point. How does traffic move from one end to the other? Because remember, the most important part of this is every time we send data out, what are we building? We're building our layer 3 information, which is our source IP and our destination IP. We have our layer 2 information, which is our source MAC and our destination MAC. Very important to understand. Now, the information in here is crucial from end to end. Now, when I say end to end, I mean if I'm trying to communicate with PC1 over to PC8, this is going to be really important information to know. And how we, and when I mean know, which means every time we go from device to device, you need to know what's in the layer 3 information, what's in the layer 2 information. So I'm coming from PC1 over to PC2. What's PC1 going to do? PC1 is going to try to ping 192.168.1.2. Now here's our fields that we have. Our layer 3, we have our source IP and our destination IP. For our layer 2, we have our source MAC and our destination MAC. Because we're trying to ping 192.168.1.2, this is an easy field to fill up. Because that's the destination that our ping request is going to go to. The source IP information is pretty easy as well, because that's us. So 192.168.1.1. Now let's look at the layer 2 information. Where are we going to get the layer 2 information from? The source MAC is pretty simple. 1111. The destination MAC is something that's a little difficult to get. Where do we get the destination MAC address when we're trying to communicate with other PCs? We get it from the ARP table. And the ARP will have a destination or a MAC address of 2222, which equals 192.168.1.2. If this is not in the ARP table, which actually it's flipped around, but if this is not in the ARP table, we're going to send out an ARP request. That's a broadcast address that gets sent out. The switch will send it out all ports. PC will eventually get it and bring the traffic back, which we saw. If it's in here, there's our answer right there. That's where the destination MAC address goes. Pretty easy communication. Now, let's build this when we're trying to communicate with someone outside our network. Our source IP is easy, but we're trying to communicate with PC1 and PC8. The destination IP address is 192.200.200.8. Our source MAC address is going to be us as well. And of course, for us to look at this, we need a destination. So we're going to look in our ARP table. Now, here's the interesting thing, though. TCP/IP knows that this is not on our network. And if it's not on our network, we cannot communicate with it. So where do we send this traffic? To our default gateway. Okay, now this is pretty interesting to understand. If it's our default gateway, what is our default gateway? Our default gateway is 192.168.1.0. I'm sorry, 1.10. That's where we're going to send the traffic to. So now our destination MAC address will be the MAC address of this default gateway. And I'm going to look in my ARP table for 192.168.1.10 I'm going to look for the MAC address. If the MAC address for my default gateway isn't in my ARP table, what am I going to do? I'm going to send out an ARP request for this. It's going to come back and say 00 colon, what was it? 168. So actually it is 01 colon 68. There's our 168 right there. And my destination MAC address will be what we change, not the IP address. There is a difference between traveling layer 2 and traveling layer 3. This is a concept that most have a hard time understanding when we talk about layer 2 and layer 3. So now, I'm going to leave the layer 3 information the way it is because I have my data sitting here. I have my layer 3 header, which is going to have the source of 1.1 and the destination of 200.8. I'm going to encapsulate this with a source of 11 colon and destination of 01 colon 68. See, at layer 2, it's not looking at the fact that I mean, layer 2, it literally is not looking at the fact that, wait a minute, this is not the MAC address for 208. It doesn't look at it like that from at all. We're just focusing on the layer 2 destination. Layer 2, which are the switches, forward information based on the destination MAC. Now, I can create an ARP entry on here on my PCs and say, hey, for this particular network range, send it to this particular MAC address. And that will be sitting on this particular router. You can make traffic go anywhere you want as long as you understand how it functions. If you get anything out of your CCNA, I want you to understand this really, really well. How this data moves. When that data, because we have a source, we got a source IP of 1.1, destination IP of 200.8. We got a source MAC of 1111. We got a destination MAC of 0168, which is this interface right here. Now, when that traffic comes up to here, and that switch, when it gets that information, knows that that MAC address is sitting here, he will forward on to router 1. Router 1 will look at that layer 2 information and says, oh, that's for me, let me open it up. And what does the router care about? Layer 3. So he knows that data goes to him, he's going to look it up, and guess what he's going to do? He's going to forward it based on the destination MAC address. And it'll come down here, and you're good to go. So let's take a look at our PC's MAC address. I have to bring this VM up here again. Now, let's take a look at the ARP request for, not PC1. This should be PC2. Let's find out the IP address. This is 1.2. I don't know why this is PC1. I changed the host name on it. That's fine. But anyway, you can see up here we're on PC2. This is saying PC1. It shouldn't be. Let's just... We could easily avoid that annoyance right there. And let's say ARP-A. Let's take a look at this ARP. Now, what is 1.100? Let's find out. ipconfig all. We're going to try to ping the 200 address and see what happens. Because in our ARP table, we have 1.10, which is my default gateway. Here's the MAC address, and there you can see it, the 168. This is something else. Don't have to worry about that right now. At it. Let's try that. Still nothing. There we go. Okay. So notice that the first one failed, and that's because of our failed pings. 10 address is my address in the house, so I always want to type in 10, so I apologize. Our first one failed because we had to send out an ARP request. So let's now take a look at our ARP. Notice that we don't have an ARP entry. Huh. Why? I don't understand. I pinged this address. Well, the reason why this is we don't have an ARP table for our entire network. Okay, so when I say entire network, I mean, let's look at it like this. So because of this, PC1 will have ARP entries for everyone that's on his network. If it's someone that he can communicate that's locally to him, he's going to have the MAC addresses of every one of those PCs. Because they're on the same network. But if I have a router sitting here, and its address is 1.1.1.5, and he's my default gateway, I am going to say all traffic that doesn't belong to me, send it to 1.1.1.5 with MAC address 5555. And that's it. That's all I care about. So the broad range of your ARP table is how many PCs is on that network. And when you are communicating with anyone outside your network, you're going to be going to the default gateway. And since you're going to the default gateway, I don't need to know what the ARP information is for that. Because when I send this to my router or to my default gateway, I know for a fact, or I'm under the impression, I don't know for a fact, but I'm under the impression that I'm going to be hitting a layer 3 device. And my ARP information is for me to communicate via layer 2. Well, this makes a lot of sense now. So with layer 2 traffic, that means I need to be using MAC addresses. And if I am communicating between PC 1 and 2, I'm really communicating via layer 2. Why am I communicating via layer 2 if I'm using IP addresses? And this is the biggest confusion that plays a factor. You're using layer 2 traffic because the switch will forward that traffic via your source and destination MAC addresses. It'll build this table with the source MAC addresses, but it will forward them based on the destination MAC addresses. And that alone is why we say it's a layer 2 network. The layer 3 traffic will never be forwarded with the layer 3 information, the layer 3 header information, until we get to a layer 3 device. So we need MAC addresses. If we're working on a switch and working via layer 2, we need MAC addresses. We need the destination MAC. If I need to communicate with an IP address outside my network, well, guess what? Here is my layer 3. This is where my layer 3 network begins. This is all layer 2. So if this is all layer 2, and notice I drew in this interface. If all this is layer 2, that means all I care about as far as the MAC addresses is what is in my layer 2 network. That's what I need to have in my ARP table. There's no reason to have the 10.200 or the 192.200.200 address, because I'm sending it to him anyway, and I'm not going to be communicating via the MAC address anymore, or layer 2. I'm going to be communicating via layer 3 because I'm going to transit a layer 3 device. Now, when that traffic comes back into this router, obviously that traffic is going to turn from layer 3 back into layer 2. Because the router is going to say, all right, I need to send this to 1.1.1.1. That's on the same network as I'm on. I'm going out that same interface. Let me look in my ARP table. Oh, wait a minute. You're telling me a router has an ARP table as well? Let's go find out. Router 1 is what we're using. Show IP interface brief. Show IP ARP. Well, look at that. 1.2. Now, 1.1 is not going to be here, remember, because we set his MAC address to all ones, and the router's not going to take that because of multicast. Now, in the layer 2 address, because of multicast, there's certain bits that can't be turned on if it's not a multicast address, and that's what's happening here. Now, because of this, look at PC2 and look at his MAC address. Here is his own interface. Wow, he even puts that in the MAC address table, right? And it even tells you what interface we need to go out of. So when we look at the routing table and say, okay, traffic's coming in on this router, I needed to go to 192.168.1.1. He's going to look at the routing, the interface, and see that it goes out of interface 00. He knows he needs to send it out this interface. He knows it needs to go to 1.2. I know I said 1.1, but he knows it needs to go to 1.2. He's going to look in his ARP table and build the source MAC address of himself, which is 168, and the destination MAC address of here. We are consistently communicating either via layer 2 or via layer 3. And that is the crucial aspect of this lesson. So, now let's get back to our drawing here. So at any given moment, you need to be able to know what is in our IP header. This is crucial. If I ask you these questions, this is one of those questions that I can almost say for sure you probably will get on your exam. I don't know. I haven't taken the new exams yet. But I can honestly tell you that this is something that you need to be doing and understanding. Not just for the exam's sake, but you should know this. And it's a lot of working parts, so it's very easy to forget. You just have to keep going back and remember. So now, PC1 is going to communicate with PC8. Let's see how we're going to build this. PC1. We're going to have a source IP of 192.168. Let's do it this way here. We're going to have a source IP of 192.168.1.1. We're going to have a destination IP of 192.200.200.8. We're going to have a source MAC of 1111. We're going to have a destination MAC of what? The default gateway. Why are we going to do the default gateway? Because this is not on our same network.